last week, it didn't go into focus right away in one class. Now it seems fine. Have you guys ever noticed that on the videos? It goes in and out of focus?
It on your face, and then when you go back there, it's like still focused close up.
But does it take more than a couple seconds to fix?
10 seconds.
10 seconds? That's kind of annoying.
No, it's okay. In some videos.
No, let's do the interval first. You can take a break whenever you want to. Sometimes.
Yeah.
The one I watched yesterday kept like, it was like, it did that a couple times, but it wasn't annoying. I mean, it
Not to the point you couldn't use it.
yeah, no, it was fine.
Awesome. All right, here we go. Here we go. So, for the penny spins. We already have a p hat. The p hat was 0.48 mil. 458. 45.8% of the time, we're going to get heads in our sample. Now, you'd be a fool to just call that p. There you go. Here's what the population proportion is. You saw how many times did p hat actually land on p in that spreadsheet? If at all. Exactly. Very, very little, if at all, that it land on p. You have to give it the interval to give it a range of values. Then we'll work on precision later, of course. So we need a margin of error. Now. And beautifully enough, we have the computation that was up there before. All we've got to do is take that critical value. You're kind of in the same spot you were with Bert and Ernie right now. We'll do this one time manually, and then let the machine do it for the rest of the time. It's very important to not waste our time doing this manually all the time. So critical value, and then we have the standard error, which is that p hat q hat all over n. And like I said, if you want to know more why this formula exists and why it works, please, by all means, watch the video and or read the proof on the Richmond Pages site. It's all there for you. Okay? All you got to do is plug values in. And we've got them all, don't we? We've got them. Z critical, if we're going to use 95% confidence, let's just call that 2. It should be 1.96. Let's not make life unbearable. Let's call it 2. We've been calling it 2 ever since 243, and that's fine. Now I'm going to put a little note next to that. 95% confidence. We're usually going to use that. Every once in a while, if you do a problem in your textbook, it asks for 92% confidence and things like that. You may have noticed I didn't put a 92% confidence row on that chart I gave you. There's a reason for that. You don't need to use the chart. The chart's already programmed into your machines. Okay, there's that. P hat is that guy, 0.458. Q hat is everything else. That's the chance of tails in this case, which would be, check my math on this, 0.542. Carry the 1, I think that's 1. And then we have to divide it by our sample size n, which, thank you, 310. Lauren, here's your precision consideration right here. The bigger this bad boy gets right here, the smaller the overriding, the more precise we get, the less imprecise we get. Thank you for that. Stacey, go.
Sorry, I forgot how to get the 542.
It's just the complement of this guy.
They have to equal.
They have to add up to 1. That's the chance of heads, that's the chance of tails. You have both things multiplied together. Very, very good. Very, very good. Fair so far? Has anybody calculated that real quick?
0.498.
Is there a 0 in front of that 4, please?
Okay, yes.
Okay, good. 0.498 would be a 50% margin of error, which puts us squarely in the between 0 and 100% sure. It's between 0 and 100%. So 0.498 makes me much happier.
Oh, actually, no. That's not what I came up with. It is 0.498 on the computer. I thought you meant in front of the decimal.
All right, something's up. Let's figure it out. Something's up. You're starting to see precisely why we don't do these by hand.
I got it.
You're starting to see precisely why we don't do these by hand very often.
I got it. It's 0.0032.
0.003. That seems too precise. Hang on. We're going to figure this out right now, Madeline. All right, here we go. Let's clear this bad boy out. Because I screw this up all the time, I'm going to do it in parts. So I'm going to start by multiplying these together. 0.458 times 0.542. Okay, so there's the numerator. That's the top. That's the top.
It's probably parentheses.
It probably is. That's why I'm doing it piece by piece. I'm going to divide that by 310. Okay, so now that is what's underneath the radical. Okay, that's what's underneath the radical. Yeah? We good so far?
Yeah.
We're going to take the square root of that. Okay, that is what is now, that's the standard error. That's one standard error, square root of all that stuff, yeah? Yeah, so far? Now double it for two standard errors. Times, this is what, not seeing its keys. I'm guessing where things are. There. Yeah. Sorry, hang on. I wish I could see my keys. Okay, there.
0.05.
Divided by, they've rubbed off, yeah. Divided by 310. That's what's under the radical. I'm just going to do this. 2 times the square root of that. There.
Yep.
That's your margin of error. Stupid Sean. Where are the keys off? So that is your percentage error. Renee, go. Please. Well, if you want to. No, you sure? What's bothering you? At what point?
Well, it's,
How did I take the square root of something and got bigger?
if 2 times the square root of that is 95%, then is
It's
the
confident.
plus the standard of error is between 90 and 100%?
Hold that thought. You're getting ahead of yourself. And I think we can take care of that momentarily. This, friends, all that number we just got is the margin of error that we then have to add and subtract from p hat.
So it's 100 minus.
All we've done is we just figured out it was a 5.6, number was 0.05, we'll call it 0.057 to give it 3 decimals of accuracy, because we did that with this. So this right here is 0.057. That's 5.7%. That's our margin of error.
So you plug that in.
That's what we have to add and subtract from p hat to set up our confidence interval. You see what I'm getting at? Thank you, Renee. Great question, by the way, my friend. Thank you.
So would you just call it 6 out in the real world?
Well, depending on the precision of your digit you're using, generally yes. Gallup will call it 3. Well, first of all, they'll call it 3 because they'll do a bigger sample. If you doubled your sample, you'd essentially cut your margin of error down by like a factor of 4. You'll see why momentarily. But yes, they generally tend to round them off the whole numbers, depending on what you're looking at. Scientific studies won't, because scientific studies generally want more precision than Gallup does. I mean, we care more about, the percentage of headache of a drug than Congress's approval rating as far as precision goes. It's not important to be 9.1% sure that Congress sucks. 9%. Right, 9% is good enough. You don't need 9.1%.
I think I need the 1.
Oh, that's okay. That's okay. That's all right. That's all right. So you see what's going on. So here's the margin of error, friends. So the 95% confidence interval for the proportion of heads we get after spinning. Not flipping, but spinning. Is found by getting this guy and that guy together. We take him and add and subtract him. So you got to take 0.458. Let's draw a little line here so we separate all this stuff. Plus or minus 0.057. So we said we're fairly certain it's not 0.458. But we're 95% certain that it's within 5.6% or 5.7% of 0.458. Let's see if I can do math in my head. Oh, that's nice. That's going to be 40.1%, isn't it?
Yeah.
That worked out well. Thank you, math. To 51.5? Did I do that right?
I swear.
Did I do that right?
Yeah.
Sweet Jesus, thank you. Which now means I do not know exactly what the percentage of heads I'm going to get is. But I'm 95% sure that it's at least 40.1% and no more than 51.5%.
So that's how we note it too? That's the range?
Well, either way, I like doing it this way rather than this way, and here's why. Can anybody see why I like this versus this? The bottom one, I put a green box around.
Well, it's got an answer. I mean, that's actually.
They both say the same thing.
But that's the actual range.
Yes, you can kind of, good, and that's what we're going to do, so that's that. You can see the whole range of values, you can actually graph it, and we're going to do that when we get back. But let's take 5, you're getting that glazed look. I want to make sure we got this far, and then we can build off that when you guys get back from break, yeah?
Okay.
Let's do just that, so let's definitely graph, because I think it's important. Break, go!